All right, good. It sounds like we've got people can hear. That's a good start. My name is Severin, and we're going to be talking today a little bit about Firebase and doing client-side projects with Firebase. Thank you all for coming, and also thanks to Elizabeth for getting everything set up for us. Hopefully you find this to be an interesting discussion. We're going to go through a few questions about Firebase, and then we're going to build a small project just to give you an idea of what you can do with Firebase. If you have any questions, if you can hold them for the end, then at the end we'll take some time to try and address any questions. But to start out, let's go through the presentation and our quick app construction. But I'll definitely try and go through questions at the end here. All right, so if everyone's ready, let's just go ahead and get started here. All right, so what are we going to go over today? So we'll start off by just talking a little bit about what Firebase is and some of the tools that it provides. And then to me, the most important question here is this third one: is Firebase a good choice for my project? This is an important question to ask yourself because, like any tool in the developer's toolbox, Firebase has a lot of benefits, but there are also some downsides to it. So before you start on a project, you definitely want to think about that. And a big part of that is how you're going to structure your data. We're going to talk about that in depth during our presentation, but that's a major consideration. So I want to make sure you have an idea about how data is structured in something like Firebase. And then finally, I'll end with a few questions for you to explore on your own, if you're so inclined, as well as some resources to help you do that. So what is Firebase? Firebase is a backend as a service. This means that Google Firebase provides you with all of the backend tools that you need so that you can focus on your client-side development. They're going to deal with servers, maintaining them, configuring them, the databases, authorization, all of these things that lets you really just deal with how the user is interacting with your app, and you don't need to worry about setting up the server and going through all of that. Firebase also has a whole suite of tools in the software development kit it provides, an API that you interact with, and we're going to focus on just a couple of those tools today, but there is a lot of depth beyond what I'm going to go through now, so if you find this interesting, I really encourage you to explore it further. Speaking of tools, so these are the two main ones we're going to talk about, which is the real-time data store and authentication. The real-time data store is a really interesting feature of Firebase in that it allows you to interact with the database in real time. So what this means is that when there's a change in the database, it's going to be immediately available to clients that are interacting with it. This happens over WebSocket protocol as opposed to HTTP. And we're not going to get too much into what a WebSocket is, except to say that it's a different protocol from HTTP where the client and the server are able to exchange messages without making specific requests. So that means that when you want to refresh the data that is being shown in the user interface, you don't actually need to hit the refresh button. The real-time data store allows you to do that automatically. The real-time data store is a NoSQL database with a JSON tree data structure, and we'll talk about that, but I also want to point out that Firebase has a new system that they've just started to roll out in beta called the Cloud Firestore, which is not real-time, and it's still a NoSQL database, but it uses a document model-based NoSQL structure, as opposed to the real-time data store, which is a key value structure, and I'll get into what that means momentarily. The second big tool we're going to talk about is authentication. Firebase provides a way to do authentication securely using OAuth 2.0 standard. This means that you don't need to worry about creating a login system and dealing with password hashing and session management and things like that. Firebase is going to handle all of that for you. You can either implement your own email password sign-in system, which is what we'll go through today, or you can use federated identity providers, which means that a user could log into your app using their Google, Facebook, Twitter, GitHub account. Personally, I think this is really great just because I have a ridiculous number of different credentials that I use for all the many sites on the internet. So it's nice to be able to give users the option of just using something they already have. There are a lot of other tools too. We're not going to get into them too much, but just be aware you can do hosting on Firebase. They have storage, they have cloud functions. And then this framework integration, which I put on here, is really interesting, and that is a way to use your favorite JavaScript framework to integrate directly with Firebase. I've used the React one in particular, and that one is really powerful. It takes advantage of the fact that Firebase is really great at real-time data exchange, and React is really great at updating the user interface as soon as the state of individual components change. So taken together, that can be really interesting. So if you use one of these frameworks or you want to learn one of them, Firebase is one option to use as your persistence layer. All right, so let's talk a little bit about the most important question, which is Firebase a good choice for my project? Like I said, every tool is good in some cases and not good in others, and the same is true of Firebase. I think it's a really interesting platform, but it is not suited to all projects. So there are a few things you want to consider up front, which is, first of all, if your data can be modeled in a NoSQL friendly structure, which is to say that you believe you can interact with your data effectively from a NoSQL standpoint, and we'll talk about what that means, then that's a good start. If you're going through your checklist, planning your app, and you just decide, there's no way I can do this with NoSQL, then Firebase is not the right choice for you. One of the advantages of using a NoSQL structure is it's extremely flexible. And what that means is, unlike with a relational database where you need to define some schema to describe what your data is going to look like, in a NoSQL database, you don't have to do that. In theory, you could say, have a series of records that represent users, and every record might have totally different information in it. That's probably not a great practice from a design standpoint, because you wouldn't be able to predict what any given record has, but you could do that if you wanted to. I would discourage you from doing that, but the point is that if you need to make changes in the kinds of data that are held within individual records, you can do that very flexibly, and you can iterate very quickly by changing the type of data that is being stored in records. With a SQL database or a relational database, that would be really difficult. Also, if you want to set up an app really quickly, Firebase is a great choice. You can get things up and running and working even just as a prototype really quickly. Maybe later you decide to use another tool, and that's fine. I've also mentioned scaling here, and one thing to remember is that a NoSQL database scales horizontally. And what this means is that as your need for data resources increases, you can scale by increasing the number of machines that are being used. So with horizontal scaling, if all of a sudden you have a huge amount of data and it happens very, very quickly, it's really easy to just add new machines on to handle all of that new data. Whereas in a relational database like SQL, you need to most of the time do vertical scaling, which is to say that when you need more data resources in a relational database, it typically means upgrading the power of your server. So you're going to have to migrate data from a smaller server to a bigger server. Sometimes that means downtime. It can get very complicated and very costly. So horizontal scaling is a major benefit to let you scale really quickly. Also, because the data store is used cross-platform, it's the same data store for the web or for mobile, a user can make a change in their data from the web and see it immediately reflected on the mobile platform. So that's another big advantage. All right, what about some situations where you probably don't not want to use it? I mentioned a couple of these a little bit, but first off, if you are expecting to need to do a lot of server-side work, you need to do a lot of manipulation of data before displaying it to the user, you need to do a lot of processing or calculations, Firebase might not be a great fit. There's limited capability to do work on the server side because you don't control the server. That's all taking place by Firebase. Also, if a data structure and enforced integrity is important to you, then Firebase can still work, but it's not going to enforce rules on you the same way that a relational database would. And what I mean by that is, in a relational database, you define your schema and you say, for example, every user is going to have a name, an email, and a hometown. You can't just all of a sudden add a phone number for a user into that database because there's no room for it. Or you might have constraints that say a user can't exist unless they have a hometown defined. In a NoSQL database, there's really nothing stopping you from doing these things. And in some cases, you want that control to stop you from doing something that is going to affect how your app operates. You want to have more constraints. And if that's really important to you, then Firebase could maybe work, but it might not be the right choice. Similarly, that goes to transactions. A transaction is when you're conditionally saving one piece of data based on whether or not another piece of data succeeded in saving. Now, Firebase has some ability to do transactions, and there is actually even a function called a transaction, but it's not quite the same thing that you get in a relational database where you can really be confident that you're only saving different pieces of related data if everything validates. Finally, the query bit here is really important. Doing queries in a NoSQL database and on Firebase in particular is possible to some extent, but is nowhere near the power that you're going to get from a relational database. In a SQL database, the ability to do highly complex, very powerful queries is almost limitless. You can really do a lot. In Firebase, you can do much smaller scale queries, but the complexity is limited. There are no join tables, for example, in a NoSQL database. So if you need a join table to relate two different pieces of data, that it can be accomplished, but it's really not quite the same. All right, so I've said the word NoSQL about 40 times already. So what is NoSQL? For those of you who aren't aware, sometimes known as non-SQL, not only SQL, non-relational. It just means a database that does not use a relational table to organize its data. And there are a bunch of different NoSQL models. The one that Firebase's real-time database uses, which is what we'll be working with today, is a key value store. It's just a JSON tree with different nodes under it, and I'll show you an example shortly. The Cloud Firestore is a document store, which is a little bit different. We won't get into that, but still NoSQL. These have a flexible data structure, as I mentioned. There's no schema, so you can start writing data to the database without ever saying what you expect the data to be. That can be good and it can be bad, but it's just something to be aware of. And then, like I mentioned, NoSQL tends to be more limited in its querying capabilities. This is changing to some extent, and there are ways to do queries in Firebase, but they're often more convoluted than you would get in SQL. Okay, so here's a quick example of what it means to be relational versus NoSQL. On the left-hand side here, we have a typical relational database with two tables, one for courses and one for students. They have primary keys, and then the students have a foreign key representing which course they're in. So it's really easy to work with this data. You do a join, you can figure out all the information about the courses and the students together, and that's great. On the right side, I've got a NoSQL replication of what we have on the left side. Same deal, just primary keys representing individual records and then the same data under them. But I've just finished describing how a NoSQL database is so much different, so this probably is not a great way to structure your data in NoSQL. And the reason is that if you were, for example, to want to find out the name, the topic of a course that a given student is in, you can't just do a join. You've got to first retrieve the record of the student, find out what the course ID is, and then do another retrieval to find out what that course is. It gets really messy, especially if you're iterating over things and doing a lot of this kinds of related querying. So there are better ways to do that, and I want to show you what a couple of those are. Some considerations first off, the big one being that if you retrieve a parent node from a NoSQL database, you're also retrieving all of the child nodes. So if we look back at our previous example, say we retrieve the students node, we're getting number 1, 2, 3, and so on, all the way out to every student we have. So if you're going to retrieve that parent node, just be aware you're getting everything that comes with it down the tree. And that's not always what you want. There's security implications there as well, that if you give a user the ability to write to a parent node, they also have the ability to write to every child node. So something to be aware of. Iteration here is something that we do a lot. We look at, say, all of the students, and we want to, say, print out some information on them on the screen by iterating over all the students. So you want to think carefully about what kinds of iteration you expect you're going to be doing with your app, because, as I mentioned, if you don't have the right data nested under each of these nodes, you might have to make multiple calls to the database to go retrieve new data. And we'll talk about some strategies to deal with that, but the big one here is denormalization. So in a SQL database, we talk about normalization, which is avoiding the repetition of data. In a NoSQL database, you're going to have to throw that away a little bit because denormalization is the name of the game here. And the reason for that is we want to prioritize the reading of data, meaning that if we want to retrieve information about all the students in a course, it'd be great if it's all there in one node and we don't have to do a whole bunch of calls to get information about those students. This does make writing data more difficult because if you're representing information about a given record in multiple places in your database, when you want to update those, you've got to do it in every place, and that can get messy, and that's one of those data integrity things that I mentioned earlier, so keep that in mind. Primary keys serve a similar function in NoSQL as they would in a SQL database. Basically, it's just a way of saying, hey, every time this particular key occurs in my data structure, I know it's related to some given object. And I'll show you an example of what I mean. So here's some other ways of implementing that same data structure. On the left, we have a more denormalized version. We've done a few things here. First off, the courses no longer have a auto-incrementing kind of key. Rather, they're using the course number as their primary key. We know that's unique, so why not just use it there? This way, we don't even have to ask what the course numbers are. We can just look at the keys. We've also included information about the students under the course and information about the courses under the students. So we're repeating ourselves here. We're storing the same information in multiple places, but that's okay. That's denormalization, and it means that if we wanted to access information about the names of every student in course 201, all we have to do is retrieve course 201's node. We've already got the student names there without having to make additional calls to the database. So that's really nice, and there are ways to even get more explicit about this. On the right side, we have one example. You'll see a node on the right side called course students. So here we're just storing information about the students in every course. There's just one example here, but imagine many examples. So the primary key, 201 here, is the same primary key being used for our course information up top. So we know that the course of the topic HTML and CSS has the primary key 201, and then down in course students, we've got 201, and we know exactly which students are in there. Now we could denormalize this even further. We could actually make a combination of the left and right where this course and student information might be repeated every time, but that's okay. We're acknowledging the fact that we're going to have repetition so that we can maximize the ease with which we're reading data. If we're constantly iterating over courses to find out what the names of the students are in those courses, then it might be worth just creating this new data structure that repeats that data because we know we're going to be accessing it all the time. So this is called flattening your data structure, flattening that JSON tree. So even if you're repeating yourself, that's okay because you've made reading the data super easy. All right, that was like a really quick down and dirty review of the big parts of Firebase, but I want to show you some of these in action. So let's build something, look at these few ingredients and see if we can put them together. We're going to build a study group tracking app. This is going to let you create a user and then log in and log out, create new study groups, and I'll show you how to work with the Firebase console. We'll do some work with authorization and with the database as well. All right, so just to give you a quick preview here, this is the app we're going to build. It's just a real simple setup where we have our different study groups here, and the user can log in, or a user can register, and so forth. But if you look at how this is set up right now, all of this data is just being contained on a sample data object that is being loaded up when we load this document. And if we look at our sample data object, you can see that this is a really naive way of storing all of this information. First off, it's not persistent. So if we make additions to it and refresh the page, all those changes will be gone. Second off, we've got every user stored and their password is stored right here. And obviously we don't want to do that. So let's fix these problems and give ourselves a persistent layer with some secure authentication. All right, so our first step is you want to go to the Firebase console and just go to firebase.google.com. There's a little button that says console. And once you get here, it's going to let you create a project. So we'll create a new project here. We'll call this LS Tech Talk Study Group. Just hit create project, and this is going to configure your project so that you can assign it a unique domain and some IDs and get you an API key so that you can then interact with a given project from your app. All right, our project is ready. That's a good start. So this is the Firebase console. There's a lot going on here and a lot of depth here, but we're just going to start out with this develop section with the authentication and the database. The other elements here, the stability, analytics, and grow, these are mostly tied towards mobile, so we're not going to worry about that too much, but be aware that they're there and you can explore them further. All right, so our first step here, add Firebase to web app. That seems like a good place to start, so let's see how that looks. All right, and this pops up just with some easy configuration information. The first thing we're going to want to do with this is to get this script tag with the Firebase JS file so that we can actually start to use Firebase. So I'm just going to throw that into my markup here. Now, if we go back, we'll refresh our app. You can see that we now have this Firebase object, and there's a ton going on with this object. You don't need to worry about all of this right now. There's more than we can go into, but I want you to take a look first at this initialize app function, and then this database function and the auth function. So those are fairly descriptive terms. Initialize app is we're going to use to connect to our project, the database, connect to the database, and auth to deal with authorization. So let's do that. So here we have some configuration information that contains everything you need. So I'm just going to copy that, and we'll go back to our project. And if we go down here, the way that this particular implementation works is I have this app object with an init method that gets called as soon as it gets loaded. So this seems like it's probably a good place to initialize our Firebase project. So let's just start by saying initialize Firebase. Now, of course, we're going to need to write this method if we want to use it. And this is a handy place to put all of our configuration information that we stored earlier. So this is going to let our app talk directly to the project that we just created. And while we're here, for the sake of convenience, I want to go ahead and store that auth object that I mentioned by calling firebase.auth and storing that authorization object on our app object so that we can interact with it just in an easy fashion. And we'll do the same with the database. All right, so if we save that, come back to our app, we can now see that both our app auth and our app DB have stored those Firebase objects on it so we can interact with authorization, we can interact with the database. So that's a really great start, but now we need to create some users. So we just have a registration form here that is going to be used by the users. And if we go down to our user registration form, there's a method called create new user. So what this is doing right now is just gathering data from the form and pushing it onto that sample data object that we were using earlier. But we talked about how that sample data object is not a great way to build an app. And then this last line here is to set a user into the session. Firebase is going to deal with that session for us. So let's go ahead and comment that out and see how to do this the Firebase way. So our first goal is to look at that auth object that we earlier stored. And this provides us with a lot of functions to deal with authorization of users, to include the creation of users. We're going to start with create user with email and password. So this is a method that takes an email and password and it creates a new user. It's relatively straightforward. So let's pass in our user, or rather our data. And one thing that I want to mention here, but we won't come back to it for a minute, is that in addition to creating a new user, this actually creates a promise, or returns a promise. Now, we're not going to get into what a promise is, except to say that it's an ES6 feature that lets you really easily work with asynchronous operations. So that's going to become important in a minute, but let's come back to that. First, we'll come back to our app, and we'll try and register a user. Okay, we fill out our forms. Oh, but we're getting some errors here. It says the given sign-in provider is disabled for this Firebase project. Well, the reason for that is if we go back into our console and look under the authentication tab, there's this little tab right here that says sign-in method. Now the sign-in method is an important configuration step so that you can authorize certain types of authentication to take place. There are two steps we need to do here. The first step is down here for add domain. By default, it has localhost and whatever the name is of the Firebase app on there. But because I'm using Cloud9 as my development environment, I need to add this domain in, otherwise we won't be able to authorize new users. So we've got that. And we also want to come up here and here are the different authorization mechanisms. Email password is what we're building now. There's phone authorization, and then these federated identity providers that I mentioned earlier, like Google, Facebook, Twitter, and GitHub. We're not going to worry about those for a moment, but let's authorize, or rather, let's turn on the email password option. And I'm going to turn this on now, but we're not going to come back to it for a little bit, but this is an anonymous sign-in. And just keep that in the back of your mind that we enabled that. We're not going to come to it for a couple of minutes. Okay, so we've enabled some new sign-in methods. Let's go try this again in our app. Register a user. Okay, so we didn't get any errors there. That seems like a good sign. And if we look back in our database, we can see that indeed we have created a new user. So that's great. The identifier is just that email that they typed in, and we've also got this user UID on the right side here. Now this is a unique ID that Firebase has created for our user, and this is important because we're going to use that as the primary key for our user later. So we've got a user registered. That's all well and good. But I want to point out that if we go look at our database, there doesn't actually seem to be anything here. So we just had this user, and they provided a Slack name and a course number and some other data, but it didn't get saved anywhere. We created the user with the email and password, but that other data up until now is lost. So if we come back to our program, this is where that promise comes into play. And we can use that promise to say, okay, if this promise successfully resolves, then I want to use a callback function, which is going to have that user object that just got created. And now we want to use this to say, okay, our user was successfully created. Let's save some information about them in the database. And to save information to the database, our first step is going to be to get a reference to the appropriate node on the JSON tree. And we can use that by using that database object we stored on the app earlier and going to a node of users. Now, there's nothing actually in this node yet, but that's okay because when we create a child node under that parent node, both will be created simultaneously. So now we can get a reference to the child node we want to create with this new user by going to users.db ref and just calling this child method here. Make sure these line up. So the child is going to be a child of that user's node. So you might be asking, okay, what key do we want to use as the key for our child node? Well, in this case, we have on that user object the UID, which I pointed out to you earlier, which is just a really handy way of identifying every user. And once we have that reference, we can use that reference and call the .set method, which is just going to write some data to that node on the database. Firebase. So this is a good start, and I will point out that because this is a promise, we could also be catching an error like this, and this is where you would deal with a case that a user was not successfully created for some reason, but for simplicity's sake, we're not going to worry about that at the moment. Just keep in mind that that's an option for you. All right, so if we go back to our app, let's try and create another user. Okay, no errors, that's always a good sign. And indeed, if we now come look at our database, we've got this user's parent node, and our new user is stored in a child node under that parent. And the primary key used to store that is that new user's UID. All right, so we're really making some progress on our app here. We've created some new users, we've logged them in, and if we point out on our app.auth object, there's a attribute called current user, and this just stores information about the user that is currently logged into your app. And there's some stuff here like the email and that UID that I mentioned is down here. So this is just a handy way to access information about your current user. So we know somebody is logged in, but if we look at our UI, we can see that nothing's actually changed. There's no evidence here to say, hey, somebody is logged in. So we probably want to change that. Let's look back in our program and talk a little bit about one of the really powerful things that Firebase does, which is allow you to set up real-time listeners. So the listener we're going to set up now is a listener that deals with whether or not the auth state has changed, which is to say, has a user logged in, has a user logged out, is a user logged in right now at all? So to deal with that, let's create a method called handle auth state change. And in this method, let's just start by storing a reference to the current context, which we're going to need in a moment. And we're going to go to our handy auth object that we have previously stored on the app and call a method called on auth state change. And this listener is going to get the user object when the auth state has changed, and now we can do some work. Whenever that auth state has changed, we can do something with the app. So it seems like a good place to start by storing some data about the user on the app so we can work with it. And then we're going to want to redraw our header, and we'll redraw the study groups as well. So one important thing to remember is that just because we set up this method set up this listener doesn't mean it's actually doing anything yet. In order for the listener to work, we're of course going to have to actually call that method somewhere. So we want to bind that method to the object. So let's also add a bind method down here. So this means that as soon as the app is initialized, it's going to call the bind method, which will in turn call handle auth state change, which means our listener is going to be set up. So once our listener is set up, we're calling the set user method and then doing some drawing. So right now, if we look up here at the set user method, we're just getting some information off of the session, but we're no longer working with the session. So let's go ahead and change that. Now we need to deal with a couple of situations here. One in that there is no current user, and one in which there is a user. Keep in mind that that on-auth state change listener is going to always fire at least once. As soon as it is bound, it's going to fire at least once to check and see whether a user is currently authorized. So let's look at our current user and say, okay, if there is no user in, meaning that value is null, then we'll just set our user on the app to null as well and make a little log to just say the logged in user. Now, how about the path where there is somebody on the auth.currentUser value? So here, what we want to do is retrieve some information about that user and store it on the app so that we can work with it. Let's get the context. Again, we'll need that shortly. The first step here is similar to when we were creating a user. is to get a reference to the appropriate node on our database. We can do that by getting a reference here to the users node. Now keep in mind, this is a reference to all users, and we don't need to retrieve all of them. We just want to retrieve the current user. So, yes, thank you whoever said typo. We just want to receive the current user. So when we're going to do that, we can use that user ID that we know is on the auth state, or on the auth object rather. So what we're doing now is we've got the reference to the users node and then drilling down to the particular user that we care about. So once you've got a reference, we can retrieve a value by triggering what's called a value event. Now, what we're doing here is just retrieving a value one time. This is where you would set up a real-time listener if you needed to constantly listen for changes. In this case, we're not really expecting a lot of changes on that user, so we're just going to call it once so we can load some information. This also is going to give us a promise and a callback function, which has what is called a snapshot in it. Now, a snapshot just represents the information at that node that you've just retrieved. The most important thing you need to know about the snapshot is this method called snap.val. And snap.val is just going to give you the actual data at that point. So we're going to take the data from that snapshot and store it on the user and then go ahead and draw. All right, so let's see how that has changed things in our app. Oh, and it refreshed a little bit too quickly for us, but you can see it very briefly there said no user logged in. That listener got triggered because on-auth state change always triggers at least once, figured out that there is a user logged in, and then it changed our interface here. Now you'll notice that we're actually missing something. There should be a button here to say we want to add a new study group. And the reason is that previously in our old implementation, we have this reset main method, which was redrawing the interface. We're now relying on that listener to do our redrawing. So just delete that, and we now have our add group button. Okay, so our next step is once we've got our user logged in, we probably want a way to log them out as well. This is really quite simple. The way this is implemented, when somebody clicks on log out, it's just going to trigger a method to the app called logout, appropriately enough. And in the old implementation, we would be removing something from the session, resetting the interface. But now we can do that a little bit differently because, again, our auth object provides us with a very handy method, simply enough, called sign out. And because this will also trigger an auth state change, our listener will fire again, causing redrawing on our app. So now if we refresh, right, the user is logged in, and we can log them out, and now the user interface changes again. Okay, so we can create a user and we can log them out. We probably want to be able to log them in as well, so let's do that real quickly. We can go down to our user login form, and we've got a method here called handle login submit. So in the old version, we're extracting some data from the form, we're validating credentials on that sample data object, and then setting a user in the session. So we're not going to deal with that anymore because we're using that auth object. And here we can get another handy method called sign in with email and password. And as you might expect, that takes an email and a password. So similarly to when we created user, this is going to return us a promise as well. So what will happen here is if the promise resolves successfully, meaning that the user was validated and Firebase will take care of all of the validation to check whether the credentials are right, then the user will get logged in. But in this case, we do actually want to handle the case where the user is not successfully logged in and inform them that there was a problem. So let's catch that error. And here, this is just a place where we can show some alert. We already have that from our previous implementation. So what will happen here is a user will get logged in, but if there's a problem, then it should catch the error and we can respond accordingly. All right, so let's check out how this goes. We try and log in as another user, but give it a bad password. Okay, good, we're getting a complaint there. Now let's try it with a good password. And good, so we got logged in. All right, so the next thing that we want to be able to do now that we can create login and log out users is, of course, deal with those study groups. Now, right now, we're drawing some data off of that sample data object. We're not dealing with that anymore, so let's get rid of that and instead see what happens if we can just set up an empty array. And what we'll do is extract data about the study groups and put it into that array, which will let us draw it. So we go back and look, it says, okay, we don't have any study groups now. All right, so the process for extracting the data is very similar to what we just did with the users. Let's set up a reference to the appropriate node. And once we've got this groups node, we can, again, trigger a value event on it. And this is going to give us all of the information about all the study groups in our app. And if it promise successfully resolves from that, we'll get our snapshot. So this is parent node, which means we're going to have all of the individual study groups under it. But the way that this particular implementation is set up is we want to iterate over those study groups and do the markup for each one individually. So we need to take the individual study groups and put them into our data array. Now, a very handy feature is that when you have a snapshot like this, you can actually iterate over the snapshot itself. And here, inside of the iteration, we're going to get all the child snaps. So a child snapshot is just a snapshot of a node that is a child of your parent snap. And we'll just take this and get some data out of the child snapshot. So here's the value for that particular group. And I'm also going to add a unique ID here. So you might be thinking, okay, we didn't make a unique ID, but we'll come back to that in a second. The point is every child node has a primary key in it, and we need that implemented onto our group object because the way the markup is implemented, we want to have that. So we can get that and push it into our data array. Okay, so we don't have any study groups yet, so nothing is showing here, but we can actually do that just directly here in the Firebase console. So let's take a look at what a study group looks like. And here's just some example study groups that we had. We've got a title, date, time zone, course, description. So we can go here into our database and we can add that node directly. So we'll create a new study group with the title, a new group. Let's see, we got a date time, which I grabbed earlier. Description, really great group. Then the course, call it 120. And I think there's also a time zone here. All right, so we've just built that directly in the database, and that is now saved in. Let's check our app. But we're not getting anything drawn here. So the important thing that we forgot that we need to remember is that this is an asynchronous operation. So as our code was executing, it did this markup as though there was nothing in the data object. So in order for this to work, we're going to have to move this up into our asynchronous snapshot call. And because we're calling some methods, let's store the context here and give this another shot. This time, we have a new group. So we created that inside the database, and it's already showing up on our interface. Now, we probably want to be able to create groups directly as well. So let's do that. We can come down to our new group form. where we were creating new groups. And you can see in the old implementation, we were just gathering some data and pushing it onto that sample data object. But since we're not working with that anymore, let's do it the Firebase way. So as you might expect, first step here is to get a reference to our groups node. So we've got that reference, but now we want to create a child node, but we don't already have a unique ID for this group. And Firebase provides a functionality where we can get a unique ID by taking that parent node, groups_db_ref, and calling push on it. And what this will do is create a new child node with a unique ID and simultaneously give us a reference to it so that we can write to it. So the unique ID that it creates is going to be the primary key in our new data. Okay, so we've set that up. Let's try creating a group. Another group. Create group. All right, click add. We've got that other group in here, and it has appeared automatically because we redrew the study groups. And if we look at our database, we can see that it appears here as well. And you'll see that this key being used for it, this is that value that was created by our call to push on the groups reference. So everything's looking pretty good. I think we're pretty complete here, but there's one problem I want to show you, which is if we log out, we're now getting this error popped up on the console. And if we try and refresh, it doesn't have access to those groups anymore. And the problem here is that the way our permissions are set up in the database, it says that you can only read data if you're logged in. So nobody's logged in right now, so we can't read that data. And if you remember earlier, we enabled this thing called an anonymous sign-in. So I'm going to show you that real quick, and this just means that an anonymous user will be signed in as soon as somebody comes to the app in case they don't already have an account, but they still want to be able to view some of our data. So let's check out our draw method in our study groups, and we'll add a conditional here to just say, hey, if no user is logged in, we need to log one in anonymously. So we'll say, okay, on the auth object, and look at the current user, say, okay, if this is null, then we need to do something. And to do this, we can trigger an anonymous sign-in on our app object, and remember to return so that the rest of our code does not execute. So now we need to handle that trigger, and we can do that by, again, using our auth object that we stored earlier. And we can just call another handy method called sign in anonymously. And what this will do is sign in a user anonymously if one is not already signed in. So you can see here we've refreshed. It happened automatically, but we can do it on our own here. And when you refresh, you can see that there's no user logged in here, and yet we're still able to see the study groups. Now, if we look at that current user object, you can see we have a current user here, but the key feature is we go down, there's this value is anonymous, and it's set to true. So the reason this is important is that you can allow users to do some things on your app if they're anonymous and other things if they're not. So if we look at our users, you can actually see that it has created this anonymous user, even though nobody actually signed in. And it's even got a unique user ID. Now, the reason this is important is that maybe you want to let an anonymous user do some interaction with your app, maybe even create some data, and then maybe after creating some data, they decide that they want to go ahead and sign up, so they create an account. Now, this anonymous user can be converted into a real user, and the data they created while anonymous will be preserved. All right, so things are looking pretty good. We can now log in. We can create a study groups, and we can view the data that we've already created. So that's a real quick whirlwind of what it's like to implement a really simple Firebase app. We learned about the console, we learned about some of the basic commands, and hopefully we've shown some of the power of Firebase, but also gotten you to think about whether it's appropriate in all situations. So if you're interested in this, there is a whole lot of depth left to go. I've got some proposals here that if you're interested, I definitely recommend you check these out. The federated identity authorization is really interesting and really powerful. I would also recommend looking into how to query a NoSQL database. It's different than you would do in a relational database, but still it's got a lot of functionality. It's not as powerful as with a relational database. We also didn't take advantage of the real-time in the real-time database here. We were using those one-time value event triggers, but that's something you can look into, how to make your app such that it will respond in real time to changes in the database. That's pretty easy to do. It's just for the sake of expedience, we didn't do it here. Check out Firebase storage, hosting, and cloud functions. And if you use one of these frameworks listed here, React, Angular, Polymer, and Ember, there are integrations. You can check those out. The React one is really great. I haven't tried the others. There used to be an integration for Backbone, but it seems like it's not really supported anymore, so that the new versions of Backbone don't work with it. But these other ones should be really good. So where do you go about doing all this? A few places. Check out the documentation. It's always a good place to start. The Firebase YouTube channel, the so-called Firecasts, are really, really good. I definitely recommend you check them out. If you spend an afternoon watching Firebase YouTube broadcasts from Google, you can really learn a lot. The Firebase blog, also really good, and then of course the GitHub repositories. And if you're so inclined, you're welcome to check out the app that we just built on my GitHub profile. There are 3 versions in there. One is called Presentation, which is what we just built. One is an established Firebase version for reference. And then there's a version called, I think I called it normal version or something like that. And that's the one that without any implementation, so you can do it yourself. Of course, go make a new project, use your own API key. All right, so that is an overview. And if you guys have questions, I will do my best to answer them. So yeah, please, if you've got questions, just go ahead and put them into the chat box or the question box. Okay, we've got a few questions coming in. Yeah, so first question, what prompted me to learn about Firebase? Yeah, I actually found it going through just a random tutorial I was looking at, learning about JavaScript, and it just happened to mention Firebase. Looked into it, I thought that it was a really interesting product, and I have used it for a few personal apps. I don't think any of them are accessible online. One that I built was a React Firebase app that I use to track my exercise. But you can really get these going really quickly, and I think it's worth checking out even just to play around with. Right, another question, are there any libraries, frameworks that make querying NoSQL easier? I don't know of any. I will say though that if you look through the Firebase blog and the Firebase videos, if you look at the older ones, they talk about how it's really hard to query. But the newer blog posts, especially dealing with the new thing called Cloud Firestore, it seems like they're implementing a lot of new querying mechanisms, which are making that a little bit easier. You can do querying. I don't want to say you can't do any querying. And if you check out the YouTube videos that I mentioned, there's a series of YouTube videos they made. I think it's called like Real-Time Database for SQL Developers or something like that. And it's a series of 8 videos that go through how to make some basic queries using the Firebase database. And it is more complicated than with the SQL database, but you can still do a good amount. You just can't do extremely complex queries. So I don't know of a particular framework, that there may be some out there. I'd love to know. If you find any, let me know. Any other questions here? Okay, Okay, it looks like that may be it for the day, but just want to thank all of you for coming to learn a little bit. Thanks again to Elizabeth for setting this up, and hope you enjoyed this presentation. And if you have any questions, hit me up on Slack, and I'm happy to explore them with you. So thanks a lot, and have a great afternoon.